In this next section, we're going to be looking at some of the nucleophilic acyl substitution reactions of carboxylic acids. So what this is where we're taking the carboxylic acid and we're substituting the OH group with some nucleophile. The first one we're going to look at is conversion of carboxylic acids to acid chlorides. So let's just say we have propionic acid, and the reagent for this is SOCl2, thionyl chloride. And what the product is, the OH on the carboxylic acid ends up being a Cl. Now in the realm of stability, in terms of the carbonyls, the carboxylic acid is actually more stable, and the acid chloride is less stable. And that's something we're going to learn about more in the next chapter. So how do we end up getting something less stable from something more stable? What actually has to do with the byproduct. So we end up forming hydrochloric acid and sulfur dioxide gas, and that's our driving force. The sulfur dioxide leaves the reaction flask and makes the reaction irreversible. So let's walk through the reaction mechanism for this. Here's the structure of the thionyl chloride. You'll notice it's kind of an analog of a carbonyl itself, with the sulfur double bonded to the oxygen. So what happens here, we're going to use a lone pair on this OH, add it to the sulfur almost like we would a nucleophile to a carbonyl carbon. The resulting product have a bond, the sulfur, O minus, Cl, Cl, and a positive on that oxygen. From here, now the negative charge comes back down, and believe it or not, the Cl is a better leaving group than the positively charged oxygen. So what we end up with is this structure plus Cl minus that was lost in that step. Now the Cl minus can act as a nucleophile and add to the carbonyl carbon. And here we're at a familiar tetrahedral intermediate. And at this stage, now that negative charge will come back down. This time you lose the positively charged oxygen. That gives you the product. Plus this unstable byproduct. So then what happens this will just lose the H and the Cl to give you HCl. And then the SO2 is the SO2 gas.